Okay, so hello to everyone who's currently joining us, and thank you for joining us this evening for the first in our series of Cosy Homes Oxfordshire webinars. We'll just give it a couple of minutes while people log in and join us before we get started properly. And in the meantime, I'm sure you've all been privy to many Zoom calls in the past few months, but if you haven't, then just use the chat. There's a chat function at the bottom of your screen which you can use to chat to us during the webinar, and if you could drop a message in there telling us your name and if you're here on behalf of or connected to an organisation, that'd be brilliant. It's just always nice to know who's on the other end of the screen whilst we let everyone join us. Yeah, we'll just give it a minute or so. Great, yeah, I can see some people saying hello. So hi to Rowena. Oh, someone here for Christian Concern for One World in the Diocese of Oxford. Brilliant, nice to have you here. Okay, I think we've got most people here with us, so we'll get started. People keep coming in as they do. So, as I already said, to those of you who were here before, you joined us tonight for the first in our series of Cosy Homes Oxfordshire webinars, which are taking place this autumn, where we're focusing on all things retrofit and home energy efficiency. For those of you who aren't familiar with Cosy Homes Oxfordshire, it's a one-stop home retrofit service working to improve the energy efficiency of homes across Oxfordshire. It's a partnership project with Retrofit Works, the National Energy Foundation and the Low Carbon Hub. And the Low Carbon Hub is where I work as your host tonight, and I'm Tabitha Whiting, the Marketing and Communications Manager there, and also looking after the marketing for Cosy Homes Oxfordshire. If you do want to know more about Cosy Homes Oxfordshire specifically, then do make sure you join us in a fortnight's time for our next webinar, where we'll be explaining the service in much more detail. But tonight we're starting off with a beginner's guide to home retrofit, and we'll be led by Douglas Drewniak, who's going to be our expert speaker for the evening. So Douglas's current role is Building Performance Manager at Wilmot Dixon in the group Sustainability. He supports domestic and non-domestic passive house projects, which, if you didn't know, in very basic terms, is a building standard for energy efficient buildings, and also on net zero carbon projects. With this, the aim is to deliver buildings that perform better, improving energy efficiency and the building's carbon footprint, as well as making them more comfortable for users of the buildings. And Douglas also previously worked with Bioregional, who many of you, if you're from Oxfordshire, will have heard of. He's also been directly involved with Cosy Homes Oxfordshire as a contractor, supporting our home assessments through thermal imaging and air tightness testing. So if you do register your home with Cosy Homes and specify that you want thermal imaging done as part of your home assessment, you may well have Douglas turning up at your front door to do that for you. So as you can tell from that very brief biography, Doug is a real expert on home energy and retrofit, and we're in safe hands tonight for this beginner's guide to retrofit. So before I pass you over to Doug, just a couple of quick housekeeping points. Firstly, we are recording tonight's webinar, and we'll circulate it to all of you as attendees later this week, and it will also be available on the Cosy Homes Oxfordshire YouTube channel. Secondly, I've also mentioned the chat function. Please do use that during the webinar if you have any comments or questions, and we have time set aside at the end of the webinar for questions, so I'll pick them up as we go along. And yeah, if you put them in the chat, then it means I can save the chat, and if we run out of time, I have a record so we can follow up with you with any questions that we don't manage to answer. So with all that said, I'll pass you over to Doug for tonight's webinar, and I'll see you at the end for some questions. So welcome, Doug.
Thanks very much. Thanks for the introduction. I am speaking from Oxford today, so in East Oxford, sunny East Oxford. And yeah, today's webinar is just going to be sort of a brief introduction to retrofit. So hopefully not too technical. We've got 60 minutes set aside for this, roughly about 30 slides. And yeah, without further ado, I'll start with the agenda and what we'll be covering in today's talk. So we've got three main parts. I'm going to start with a bit of context. Context of both sort of the UK housing stock and the housing situation, but then also some background on what's happening with the climate and why this is important, etc. Then we'll go into the main part, the introduction on retrofit, and sort of covering different measures as they apply, And we've also got a little bit of a section on the new green grant that is coming in September. So we'll be covering that in a little bit. And yeah, sort of the last part is round about 15 minutes for Q&A. So as we'll be going through this presentation, just drop any questions into the chat bar and we'll get to them at the end. Okay, most of the housekeeping has been covered already. Just to reiterate, we'll have a recording at the end and you'll also get a copy of the slides. So don't worry about anything that you want to keep as a record. Starting with context. So I'm going to go back to COP24 in Paris. And that was sort of the first time that the conversation changed from whether climate change is happening to actual timescales. And those timescales are shortening rapidly. So there's a real sense of urgency. And just to sort of stress that point, 2020, even with COVID in place and the whole sort of travel restrictions, is looking to be sort of a record year in terms of surface temperatures again. So this stuff is urgent and sort of really matters. And now, with sort of a lack of top-down government policy addressing this, there was an initiative to do this bottom up by the councils, and you can see on this slide a summary of all of the local authorities that have declared a climate emergency, and this is really putting pressure behind this whole agenda, and that led to the drive to net zero carbon homes, which is targeted to happen by 2050. So things are moving in the right direction, certainly. A quick note on One Planet Living. So my previous job was with Bioregional, and you might have come across that sustainability framework, One Planet Living. The basic concept is basically that if everyone lived like an average UK citizen, you would need 3 planets to sustain our lifestyle. So you can see below that a breakdown where energy and resources is currently spent, and housing is a huge portion of that. So those figures sort of constantly change, and different studies have slightly different figures, but it's sort of around a quarter of that impact that we're looking at in terms of energy use in homes, and also all of the resources that are spent in sort of fitting out and building new homes as well. So it has pretty big impact. So where does energy efficiency come into this picture? And this is just an example of EPCs. So you're probably aware of the EPC energy efficiency rating scale. So this colored scale. Every new home that is now sold on the market or rented will require one of those certificates. And I've already mentioned the drive to net zero by 2050. And what that means is basically that we're looking at all homes. So that's both existing and new homes to eventually have an EPC of A. So that's 100 points and above. So you can see that very top green bar. Currently, so estimates in 2018, this is by the English Housing Survey that is sort of annually produced by National Statistics, estimate that there's about 10,000 EPC A rated homes currently in existence. So if you think that the current housing stock of the UK is probably in the range of about 24 to 25 million homes, 99% of the homes will need to be upgraded, will need to be made more efficient for us to reach net zero carbon by 2050. So that's kind of the scale of the problem that we are trying to address with Retrofit. And now really going into the main part, sort of an introduction of Retrofit and an explanation of energy efficiency in various aspects. So Retrofit, a very simple definition, is adding or changing something to your home that you didn't have when that was constructed. and it's usually aimed to make your home more energy efficient and more comfortable to live in, and cheaper to run in terms of bills and outgoings. And the works can consist from exterior works, interior works, and it can also cover building services, so new heating system, more insulation, or better windows typically. So that's the kind of measures that we are going to go through in detail today. And this slide is really to sort of give a very simplistic way of what the starting point is for most homes currently in existence. So the average UK home looks something like this diagram, and you can see most homes have probably had their cavities done. So that's that very slim line in the walls. So that's cavity insulation. Most homes will probably have had the windows replaced at some point. So probably looking at a double glazed window system. Most homes typically have the ground floor uninsulated, so either suspended timber or a concrete floor. So that's currently not insulated. A lot of homes also have a chimney, so whether that is a blocked up chimney from a previous fireplace, or sort of still in use as part of a sort of stove setup. And a lot of homes will have some sort of loft insulation. So that doesn't necessarily have to be in the slope, that could be horizontal, but that's sort of in general terms where most homes are. So you haven't got a continuous layer of insulation. This yellow line is not continuous. There's no continuous or designed air barrier in most homes. There's not much control over ventilation. So ventilation increases and decreases depending on things like the wind, the weather, and so the type of construction that you're looking at. So you've typically got a patchwork design of new and old measures. They haven't really been holistically thought out and just added at various stages of the existence of that building. So that is typically the starting point. Sorry, wrong direction. And what an efficient home looks like in comparison. So this diagram was pinched by me from the Passive House website. The concept is basically a continuous yellow line, continuous layer of insulation, a continuous designed air barrier, which is the red line to the inside of that. You typically have a very airtight shell envelope that is then controlled by mechanical ventilation. And that mechanical ventilation system ideally is combined with a heat recovery system. So those are typically called MVHRs, so mechanical ventilation with heat recovery. And they just ensure that incoming cold air is warmed by the sort of warm exhaust air in a nice and neat process. So this holistic strategy is where everything is interlinked, thought out, and measures support each other. So it's more of a holistic approach of a low energy building. And if you wanted to compare that to some kind of a very basic model to get your head around that, because that was sort of quite construction-y. So if you think of a pot of coffee, your pot of coffee is on the right-hand side. It's roasting hot. It's just been percolated. It's warmed by the coffee machine currently. So most homes are currently, they've got a little bit of loft insulation. So you can think of perhaps a tea cozy, some kind of knitted solution that you would put over the top. It's full of holes. It'll help a bit to keep the warm air in, but it's nowhere as efficient as a thermos flask. So you can see a thermos flask on the left-hand side. And of course you can pour steaming hot coffee into that thermos flask, and that'll be kept warm for hours. Or you can also put in a cold drink, and it'll stay cold for that same duration. So the idea is that a very airtight and a very insulated shell keeps both warm in winter and cool in summer through its design. So that's the kind of sort of principles that we're trying to instill through a very thought out and holistic sort of retrofit strategy. So this diagram that I'm currently looking at is breaking down some of the heat loss into different building elements to give you an estimate of perhaps priorities and starting points of different elements. So the bottom x-axis at the moment is sort of a breakdown in percentage of different elements of the building, and then on the y-axis you can see different building elements such as the ground floors, the first one, ventilation losses, windows and doors, external walls, thermal bridges, and roof or ceilings. And this is based from some work we did in Chalbury, so Oxfordshire, a study of sort of typical 1970s homes. So we did some thermal imaging surveys on those homes and some air tightness tests, and then ran them through SAP software, which is sort of a very simplified energy model that you can create for buildings for building control purposes. So you can see ground floors typically responsible for about 25% of energy losses in a typical home. So this will depend on different cases and your starting points. Ventilation losses are sort of typically around 15 to 20%. So 15 to 20% of your heat loss is just currently lost through ventilation, and not sort of having an efficient way of getting fresh air into your house. You can see windows and doors are currently sort of just above 15. External walls, most external walls now will have had some sort of cavity insulation upgrade, so typically responsible for about 15% of the heat loss. And then thermal bridges can be anything from junctions, so junctions from walls to floors, junctions around windows, or sort of bits of construction like steel and joists and so on. Lastly, the roof and ceiling, so probably the most insulated part of any existing home, and yeah, the heat loss is probably estimated around 5 to 10%. So that is really just to give you a bit of a understanding of potential priorities and sort of where and to what scale energy is lost in homes. So where to start on this journey of retrofit? A good point to start is just taking stock what the issues are in your home. So those issues can be anything from damp or mold, or typically you just want to create a more comfortable environment, or perhaps you've got a home improvement project already in mind, such as upgrading your kitchen or an extension. So it's just sort of a starting point to design what your priorities are. And the next step, a good next step to then go is to look at your sort of current energy performance. So as mentioned already, the EPCs can be a good starting point. Most homes will now probably have an EPC, and some of those EPCs will give recommendations of measures and where those measures might take you. But also just to look at bills, so energy bills, your gas bill, your utility bill, to see so the context of how much energy you're using. Another idea, or yeah, another sort of useful thing you can consider is doing thermal imaging. So I do thermal imaging surveys for Cosy Homes, and those are typically done in winter time, and just show you externally or internally where heat is lost to the outside. So where you're currently leaking heat through the fabric in terms of a useful sort of colored picture image. The next point is to sort of wrap those earlier points into a bit of a plan and to form a scope and sort of note down priorities. And that doesn't have to be very detailed. It's literally just a few bullet points, because you probably want to approach a professional or a program, and it's good to sort of be able to communicate what you would like to achieve in this. To sort of wrap those up in one go. Also economies of scale, if your builder can sort of widen the scope of what he's doing on the project. And lastly, just to check for grant funding opportunities. So there's always new programs being put into place, and the Green Homes grant currently sort of starting in September is a real good opportunity to get a bit of support on that journey. Yeah, and lastly, just to approach a professional or a program to help you along the way and avoid some of the common problems that happen in these kind of yeah, projects and scenarios. And now really starting to go into some of the specific measures. So covered the basics of what you want to do now. So some of the more sort of technical bits and pieces to consider. And the first one's wall insulation. And wall insulation, the first sort of question is external or internal. External is typically more efficient. So external, if you think back of that sort of wrapping around a continuous layer of insulation, it's a more efficient way of reducing heat loss. Typically, what you're looking at is sort of yeah, between 150 and 200 mils of insulation that is then finished with external render typically, but you can also finish that off in timber cladding or sort of brick slip. Whether you can do external wall insulation will also depend on the on your area, and if your building is listed, for example, or sort of in an historic area in that context, or perhaps even want to sort of preserve the look. If you have a brick or sandstone finished home, then the next best thing to consider really is internal wall insulation. Internal wall insulation is suitable for most homes. It is typically applied in thinner layers, so to speak. So whereas external insulation can be as thick as 200 millimeters, with internal insulation you're probably in most cases below 100 millimeters. Again, you finish that with a plaster, and that can help to improve the U values. So target U values I've just mentioned very briefly in the bottom. That is something that you want to discuss with your retrofit coordinator or your builder or your architect that you employ. Typically, what you should be aiming to achieve in the external walls is somewhere between 0.15 and 0.2 in terms of U value, and that will ensure that sort of you're fit for sort of future home standards, and you don't have to do works twice. So what you don't want to do is to aim for too low and only apply, say, 100 mil external insulation and risk having to do the whole process again in 20 odd years or so. Moving on to briefly talk about cavity insulation. So most homes will now have had some sort of cavity insulation that is typically blown either fiber or sort of beads. So you get a builder in or a contractor that typically inserts that between the internal wall leaf and the external wall leaf. Some of the problems you can see on this slide as well is if the internal wall cavity hasn't been cleaned. So if you've got mortar droppings, you have perhaps wall ties, those can restrict the even spread of that insulation in your wall. So sometimes you get pockets where the wall isn't insulated. Depending on the type of material that was used, you sometimes get slump. So the insulation material just gradually settles over time and sort of opens up other areas where you might get heat loss again. A thing to mention is even very well done cavity wall insulation or topped up cavity wall insulation will probably need additional insulation to get you towards that net zero carbon home that we've already mentioned. So that drive to very efficient homes. Cavity wall insulation will not be enough to achieve that. So you will have to have additional either external wall insulation or internal wall insulation. The next thing is loft or roof insulation. So most homes will probably have a cold roof design, and what that means is that you've got insulation that is applied horizontally along the loft floor. Might be sort of 150 mil mineral wool is sort of relative standard. Other sort of a smaller percentage of homes might have a warm roof design, and what that means is the insulation is placed in the roof slope between the rafters, and typically you have to work within the size of your rafters, whatever the dimension of the timbers is. You can play with how much insulation you can fill. Nowadays, to sort of achieve decent U values, what you're looking at is, so this depends on the materials that you use, the insulation materials. So different insulation products have different efficiencies and sort of resistances. So if you're just looking at something very basic, such as mineral wool, you might want to achieve 350 to 400 millimeters of thickness. And another thing to watch out for is storage. So a lot of people store boxes and various items in the loft, and compressed insulation. So if your starting point is 200 mil insulation and you have a lot of boxes in your loft and that's compressed to half of that thickness, you're probably also looking at half the performance. So performance does decrease with insulation being compressed. So that is something to be aware of. But there's various solutions that can address that. So if you have a sort of a raised platform or stilts, or use non-compressible insulation products, then you can store directly onto that. Brief mention of heating systems. So a lot of people will be on gas in Oxford, and gas boilers are most cost effective to deliver heat. But you should be aware that they're slowly being phased out. So in the new build sector, that cutoff is 2025, where new homes won't be allowed to have fossil fuel heating systems in place. There's probably going to be a sort of a small overlap until that kicks in with existing homes. That might be sort of 5 to 10 years. So you're sort of looking at the 2030s where gas might be phased out, but there's a lot of movement in that field. So that's certainly not set in stone yet. What you should also be aware of is the UK electricity grid. So the supply of electricity is decarbonizing very rapidly. And we're sort of projected to hit parity between gas and electricity this or next year. A lot of the instance, sort of on a sunny or windy day where you have a lot of renewable energy contribution, that is sometimes already lower in sort of carbon emissions. Electricity is lower in carbon emissions than gas. So that is rapidly happening. So the future does look very electric. Electricity is also more expensive than gas, already mentioned. So typically 2 to 3 times more expensive. So if you want to avoid higher bills, a really good solution is our heat pumps. And heat pumps just improve that cost and carbon savings through their coefficients of performance. So a heat pump in very simplified model works a bit like a fridge in reverse. So you're dumping cold to the outside and heat to the inside. So it's the same kind of principle. And the coefficient of performance, what that means is for a unit of electricity that you use in your heat pump, you typically get about 3 units of heat. So that conversion is 1 to 3, which is very efficient. If you're only on direct electrical resistance heaters, you might have 100% efficiency, but because electricity is still more expensive, you're looking at higher. A neat way of both achieving sort of low carbon emissions for heating systems, but also unlocking the cost element of that. The next item to look at is windows, so especially double or triple glazed units. And nowadays there's not that much difference between a very efficient double glazed unit and an inefficient triple glazed unit. What you typically want to aim for is, again, that U value, and that's combined U value of glazing and frame of better than 1.2. And there's another sort of useful metric to be aware of, is the window energy rating. So you're typically looking at B or better in terms of that rating. So a lot of emphasis with window systems is position. So you typically want to have the window in line with your main layer of insulation. So if you have external wall insulation, you sort of want to avoid the window system being in line with just masonry or sort of proud of that. So that's a neat trick to think of position, but also integration. So you want to have an airtight link back to your wall, so typically taped or sealed in other ways. Another thing to be aware of is that triple glazed systems will raise internal surface temperatures, so they typically tend to be more comfortable, so you have less drafts. Drafts sort of sometimes appear just by the difference of surface temperatures. So you get sort of secondary drafts just by the surface of the window being cooler than the rest of the room. So triple glazed windows can avoid that. What they're also really good is at dampening noise. So if you're beside quite a busy road or so beside a school, triple glazed windows can really alleviate those kind of noise related problems as well. What you want to be aware of is that if you change your window systems, and this has led to a lot of moisture and mold problems in existence already, if you change window systems, what you typically do is improve your air tightness. So a lot of existing homes, sort of 1950s, 60s homes, have had double glazed windows installed at some point, and that's typically the time when the first mold problems occur. So you get condensation, and that leads to mold problems, and that's typically around windows and sort of other junctions in the room. So when you replace your windows, what you also want to think about is how you create mechanical, a means of efficient ventilation as part of your retrofit strategy. So we're about halfway. Just wanted to check if there are any sort of urgent questions at this point. Anything that sort of relates to these slides that we've covered. So just checking in on that.
Yeah, sure. So we have had a few questions. We have a couple on measures, which might be useful to pick up now, since that's what you're kind of doing. So we've had one question, and if you do have questions on measures, feel free to pop them on the chat now, and I'll ask them to Doug whilst we're stopping. So we've had one question from Harriet, who was asking, she said she's not too clear on the difference between ventilation losses and windows and doors. So maybe just expand a little bit on ventilation and what that looks like in a home.
Yeah. So heat loss has sort of typically, three different modes. So you can lose heat by conduction. So if you're touching a cold surface, you're conducting heat. But you can also lose heat through convection. So that's sort of secondary currents of air. And then air tightness or ventilation losses really come into play as you've just heated the internal warm air in your home, and if you have any sort of cracks in the fabric or gaps around windows and so on, that warmed air, so you're using energy to warm the air, just is lost to the external wall through infiltration. So typically an airtight building has a lot less of those losses than sort of a leaky old home where a lot of that warm air is just being lost to the outside.
Great, thank you. And then we've had a couple people ask specifically, what is mechanical ventilation?
Okay, so mechanical ventilation covers a whole wide sort of field of different systems. So most people are probably aware of intermittent extract fans, which you have in your bathroom. So those typically come on with coupled to the light switch, or perhaps there's a sort of a delay that is plugged in. So they're typically in one room of your house. They come on for set amounts of times, and so extract air from wet rooms. More advanced systems, they're typically centralized. You have a central fan and you have some sort of ducting system that extracts stale or moist air from different rooms. So that's typically kitchens and bathrooms, and then supplies fresh air into bedrooms and sort of living areas. So you have a whole range of systems already mentioned. You've got MEV systems, MVHR systems. So you've got systems that recover heat and some systems that don't recover heat. You've got centralized systems, so a single fan and ducting, or you have decentralized systems. So that would be multiple small fan units. So there's not one system that is appropriate for any one situation. So that depends on circumstances, space, so the type of fabric. So those kind of questions can really be asked with your retrofit coordinator that'll be able to help you on that, or your architect or builder. Any more? Should we push?
We have had a few more measures,
Yep.
but I think just one, I'll leave them for now so we can get through
Yep.
the rest of the content we can pick up in the end. But just as you mentioned, retrofit coordinators, we have had a question from Connor about the role of the retrofit coordinator and how could you find a local one?
Yeah.
Just have any advice on that?
Yeah, so a retrofit coordinator is typically someone that has undergone training. So they've got a basic or a good working understanding of different measures, how they work together, and good principles of energy efficiency. And your coordinator will typically sit halfway between the builder and perhaps an architect, or builder and the client. So they will help you with the coordination, planning, design, take a lot of that stress away from you, and help you avoid sort of common mistakes that if you're new to this subject will naturally sort of happen. What they will also help with is they have a vetted sort of list of suppliers and builders. So those are trusted contractors to sort of get rid of the bad eggs and those people that sort of do unreliable or sort of bad measures. So they can be really helpful in that process. Okie doke.
Thank you. If you carry on with your slides, and then we'll pick up more questions at the end.
Yes, we've got probably roughly about seven to 10 minutes, and then we'll be at the Q&A. So we'll cover the rest of the questions in that section then.
Great.
Okay, so we've covered a lot of sort of different elements of the build, and now just a really quick note on the value of having surveys done. So this is just sort of a quick stop on thermal imaging. So thermal imaging can really be helpful in that process of identifying where you're leaking heat from and what sort of the issues are. So this image is from a 1970s, I think, property that we surveyed in Chalbury. So it's an external shot of the back of the house, and it's quite typical construction. You can not really see any issues by looking at it from your naked eye. Next shot is then a thermal image overlaid onto that. You can probably see at the lower end of the door reflection of myself. So that is just my heat signature of the body. But if you're not trained in this thing, this image will probably not tell you too much either. So what you can then further do is sort of an analysis. So you can set the range, the temperature range that you would like to look at. And that sort of gets rid of the noise and just highlights the issues. So that's the last picture. So red is, so now we've basically removed sort of the areas of the image that are not telling us that much. And the red is really where heat is currently lost at a sort of elevated rate. And you can see under the windows in the first floor, there's a large area of uninsulated cavity wall. And in this instance, there's a high chance that the material that they use, sort of that insulation infill, has slumped, so has settled over time and left a gap where heat is currently lost through the wall. So those kind of things can highlight external issues that you're probably not even aware of just from living in a home. Another note on the value sort of surveys, air tightness can also be quite useful, because air tightness values can range significantly from one build to the next. They can depend on the builder, the type of materials that you use, the type of design, and so on and so on. So it's sort of hard to guess without doing a test what that might be for your house. So this is results from a study that we did again in Charlbury. So 6 homes. You can see the average air tightness currently marked by the dotted line is roughly below 8. So just ignoring the units at the moment, because not to confuse you, but lower is typically better. So towards 1 is a very airtight home, and above 12 you're looking at quite a leaky dwelling. So the average here is just below 8, 7.9. And the threshold where you should consider mechanical ventilation, so that's the systems that we already mentioned, is advisable below 5. So below 5, your dwelling's typically quite airtight, and that could lead to things like moisture buildup. So you certainly will never suffocate in a very airtight home, but you might have buildup of moisture just from cooking and so on. And just to illustrate on that, so from SAP modeling, we know that the total heat loss from ventilation, so that is anything planned and unplanned, so that is opening windows, but also infiltration from just cracks in your fabric, can be 20%. And building regulations require roughly, so that this depends on the size of your home, 13 liters per second, which is 45 meters cubed per hour on average. So based on that average air tightness that we measured in Charlbury, we were roughly double as what the recommended ventilation rate was for those buildings. So we were over ventilating those homes. What typically happens is you're over ventilating in the rooms that you don't need, and you're under ventilating in places like bathrooms and kitchens and so on. That's what typically happens. So without a mechanical ventilation system that does that in a controlled way, sort of issues around of where that happens and doing that in a controlled manner. Moisture is produced anything from cooking to breathing. So sleeping at night, you create quite a lot of moisture, but also washing. And if you imagine one of those office water dispensers, that can be anything from 5 to 15 liters, that is typically what a household produces in moisture per day. So just imagine one of those office water dispensers being opened and just spilled all over your house. That's the kind of moisture you're looking to get rid of every single day through ventilation. So that's why that is so important. It's not necessarily the oxygen and the pollutants, but it's the overriding thing and an issue in a lot of homes is moisture buildup. So the mechanical ventilation system that we've already mentioned, most homes are over ventilated in common areas and then under ventilated in wet rooms, and ways to avoid that, there's sort of single room decentralized systems that you can use. So they can also be combined with MVHRs, so you got the heat recovery. So if you currently have an intermittent fan in a bathroom, you can replace that, so the same opening in your wall, and you could use a product like that, which sort of recovers the heat, but is also on constantly, sort of a very sort of low level. You can again combine that with demand control, so you can have a CO2 or a moisture meter sensor that sort of senses when that fan ramps up and down to sort of increase and decrease ventilation. So there's a lot of different systems out in the market, and again, your retrofit coordinator can help with that process. So we've mentioned a lot of different measures above, and the effectiveness of those different measures is something we haven't really touched upon, or haven't really touched upon yet. So this diagram is basically an estimation of space heating demand. So you can see on the x-axis, you've got kilowatt hours that are normalized by floor area, so by meter squared per year. You've got a base case, so this is sort of an average house that might have a space heating demand of 113 kilowatt hours. And then with every different measure that you plug onto this base case, you can see that space heating demand reducing and reducing and reducing. So air tightness measures might get you to 110. Improving the roof will get you a bit further to 108, triple glaze to 106, doing your external walls to 100, improving your floors to 92, and then combining all of those things. So those were sort of treated in isolation, and if you're doing all of those as a part of a holistic retrofit plan, you could be looking at somewhere in the region of 60 kilowatt hours per meter squared per year. And then remember that heat pump with the coefficient of 3. So suddenly you either have an air source heat pump or a ground source heat pump delivering this a coefficient of 3, and you're actually only using 20 kilowatt hours per meter squared. So that's sort of to give you a bit of a feel of what different measures might do. So in summary, things to consider when planning is sort of the what and why. So assess your starting point, compare, plan, and then also look to future-proof that you're doing this once and you're doing it to the right scale and effect. What order to sort of prioritize. If budgets are restricted, you might want to start on the very effective measures where the low-hanging fruit, so to speak. That can be a north-facing wall or somewhere where you're really losing a lot of heat. And when is really to consider lifetime of different products and measures, repair cycles, and combine those. So if a roof needs doing, combine that with the right levels of insulation. How really involve a professional retrofit coordinator if you can, and program, which will make the process a lot easier. So you get quality and avoid common mistakes that you might happen if you do this by yourself without sort of a track record and experience of what you need to watch for. So it's really sort of shortening that learning curve. And other tips is really sort of leverage grant funding where that is available. So this last slide is before we go on to the Q&A, is to just give you a very basic overview of what the Green Homes Grant does, and what to be aware of. So this government grant is coming into place in September, and is being put into place to support energy saving home improvements. Typically this the grant level is capped at £5,000. So measures are covered to 2/3. So if you're doing any energy efficient refurbishment works to a total value of £7,500, you would get £5,000 from the government towards this. The way it's administered is typically you apply for this through the website. So there's a portal that I've linked to on this page, and you then get a voucher for the works that you requested. Those measures are typically divided into primary measures and secondary measures. So primary measures are typically insulation and things like heat pumps, and then secondary measures could be controls, glazing, so new triple glazing or doors. There's sort of different rules attached to this grant funding system. So a minimum of one primary measure needs to be put in place before you can fund secondary measures. So you need to combine insulation with, so if you're looking to do windows, you need to have some kind of other primary measure in place first. As mentioned already, applications are going to go live in September, and the grant funding is going to be available until March 2021, I believe. But now really to open this up and to cover remaining questions that were sort of raised in the chat. So back to you.
Great, thank you, Douglas. Yeah, I think everyone agree that was a really informative presentation, and I hope everyone feels like they've learned a bit more about retrofit. I can tell by lots of the questions, I think people are feeling inspired to do work. And yeah, we have had lots of questions. So we've got kind of 10 minutes left for some questions. So I'll ask what we can, and if we miss any out, then we will, we mentioned earlier, we'll circulate the recording later this week. So I'll try and include any answers that we don't manage to get to in that. But yeah, okay, so let's crack on with some questions. So picking up, I guess, from the last slide, we've had a couple of comments about people feeling concerned about contractors. I guess you've kind of reiterated the fact that you really need to make sure you have a good a retrofit coordinator on side, and you've got good contractors. And so part of the Green Homes grant is all installers have to be Trustmark certified. So we've had a question about, you know, how can I ensure I get a contractor that won't disappear if something goes wrong, or how can people make sure that they're finding the right contractors to do this work?
Yeah, so that's a really good question. And what you really want to avoid is getting someone in that has no track record, has no reviews that you can rely on, and that kind of process is built into the Cosy Homes retrofit program. So there's a list of or a pool of suppliers that have been vetted. They have various different trust marks or accreditation, but they've also been used before. So going through this process avoids you having to tender and approach builders yourself. So there's a bit more cloud, but there's also track record. It is worth probably mentioning that this Green Home grant is linked to certain certifications. So I think one of the ones is Trustmark, another the micro generation certification. So that's MCS accreditation that you'd be looking at. So going through this route of the Green Homes grant sort of filters out some of those builders that might not have any accreditation in that field already.
Yeah, thank you. And I think it's worth saying from the Cosy Homes point of view as well. So if you work with Cosy Homes, every house that we retrofit will have a retrofit coordinator assigned to it, and we also have kind of a list of trusted contractors who are all Trustmark or MCS verified and part of the Retrofit Works cooperative. So if you want the support and you want someone to help you and project manage it and make sure you're doing it right, then I really would recommend having a look at the Cosy Homes service. Yeah, that's just my 2 pence on that. Okay, great. So we've had a couple of questions as well about new homes. So is there a minimum EPC rating for new homes? Yeah, anything on kind of new build housing retrofit?
Yeah. Yeah, another good question. So EPCs, well, a link to building regulations. So building a new home will require to have an EPC certificate. That's sort of Part L, which covers energy efficiency measures, has minimum requirements on builders. But what sometimes happens is that an application goes in 4 years ago, so the standards that the house is built to might be 4 years old, so they might be slightly outdated. So we mentioned, or I mentioned beforehand, that EPC A level. So that is typically a score of 100 points or better. Is generally what you're looking at in terms of a home that is zero carbon or approaching zero carbon and is fit for the future. So anything below an EPC of A will probably have to have some sort of measure undertaken in the future. EPCs are a sort of a rating system that also factor in cost. So what you need to be aware of, that the EPC can be influenced by the heating system. So if you're on sort of electrical resistance heaters versus gas boilers, will have an impact on the EPC score. So there's sort of slight things you need to be aware of, but typically what you're looking at in a home, a future home, or a home that is fit for zero carbon 2050 net zero carbon, is typically looking at EPCA, and that is new build or sort of a refurbishment scenario. Thank
you. Yeah, so I think something that's resonated with a few people actually is what you said about floors being a really important area of heat loss. So it seems like a few people are kind of shocked about that being, you know, a really amazing difference between having energy efficient flooring and what that can do. So I had a couple of questions on that. So, most of them just asking kind of what's the best action to take, or what's the best place to start with improvements to floors?
Oh, that's another good question, and there's so many different answers to give to that question. So it depends on the floor system, I think, is the starting point. If you have timber floors, and typically sort of timber floors are suspended, so you've got a ventilated underfloor void, those are typically easier to address because what you would do is lift the floors and apply insulation between the joists, and perhaps an underlay of some sort and sort of a membrane to make this whole airtight. So that's something that can be done, I'm saying relatively easy, but it's certainly a lot easier than a concrete slab. So if you've got a solid concrete ground floor, that's a lot more difficult to address, because what you're typically looking at is either ripping the floor out and putting insulation in place and then a screed over the top. So that is a lot of work. Or you're just looking at an overlay. So you have a layer of thin, very high performance insulation over the ground slab. But what you're losing then in that scenario is you're losing floor to ceiling height. So there's not an easy answer, and there's not sort of a one size fits all solution for that. So it really depends what you have in place. I'm aware of a project where concrete floors were uninsulated and ripped out as part of a passive house retrofit project. So in that kind of scenario, you're really looking at very intensive building work. So you're certainly moved out of the house for a period of time, the house being gutted and then completely sort of reinstalled. So some easy wins might be something like underlays, or floor underlays can be, especially sort of vacuum sealed insulation products can be very efficient. And a lot of the times, what really helps already is just preventing drafts. So drafts can sort of make the perceived temperatures, especially around your feet, and make the room feel a lot colder than what it actually is. So yeah, so a whole different array of answers. Unfortunately, not an easy one to address.
Yeah, it's always really tricky to give kind of blanket advice on retrofit, I guess. And we have had quite a lot of the questions have been like really specific, or, you know, I've done this to my home, or what would this type of home work? So I'm going to leave those ones. So if you've asked a question about like a specific measure, I've written them all down, and we'll try and kind of answer them offline, but just because they're not going to be relevant to everyone, and it is really hard to give that advice, as you know, that answer's demonstrated. But yeah, a couple of minutes left. So we've had a couple questions on kind of global warming and the impact that that's having in the summer, and whether, you know, now we're actually going to need to be making sure that our homes are cool in the summer as well as warm in the winter. So do you have any advice? So someone's asked about heat reflecting windows, or just, any thoughts on retrofit and cooling in the summer?
Yeah, really important topic. So a well insulated and airtight building will keep your temperatures cooler in summer and keep the heat in winter. But what that also interfaces, and what's really important in this kind of scenario, is the windows, so the glazing. The glazing can keep thermal gains in different ways. So what to be aware of is that the G value that defines how much of that heat that you gain through solar gains is kept in, is quite low. So if G values are low, you get less gains. So that kind of question is really answered through sort of more detailed thermal modeling behind before you start the measure. So you sort of need to look at everything holistically, so window glazing systems and the levels of insulation. So those two will always need to be looked at in one sweep. It is probably worthwhile mentioning that people might already be aware from traveling on the continent, a lot of homes say in Germany, where I'm from, will already have external shading over windows, and that's just something that will need to be looked at as the climate warms. Is to keep excess gains out just in sort of peak summertime months, and external shadings very efficient, or internal blinds. So there's a lot sort of more emphasis on managing solar gain and the sun, but a well insulated building and efficient glazing systems will help you a lot towards that journey of managing sort of temperatures in a controlled way and comfortable way.
Great, thank you. That's really interesting. Well, there are still lots more questions, but we're at 7 o'clock, so we'll leave it there for now. So that's all we've got time for tonight. We will try and answer any missed questions, as I said before, in the kind of follow-up email that we do. But if you do have a question that you want to make sure that we answer afterwards, if you just email it to info@cosyhomesoxfordshire.org, I'll just pop that in the chat as well. Then it will come to me and I'll make sure we get back to you. So yeah, before we sign off, just a quick reminder again that this is the first in our series of Cosy Homes Oxfordshire webinars, and we have 3 more to come, which will be fortnightly on Tuesdays.
I'm just going to go forward to that slide.
Thank you.
I think we've got that
yes,
covered
we
here.
do. Okay, brilliant. Yeah. So the next one is an introduction to Cosy Homes Oxfordshire. And that's on Tuesday, the 22nd of September at the same time of 6 p.m. So I think if tonight's webinar sparked your interest, if you're thinking about what you could do for your home, and you'd like support to make sure you're doing it correctly, then that is where Cosy Homes comes into play. And I definitely recommend registering for that webinar to find out a bit more. And after that, we have 2 more webinars, which are on specific measures, both of which have been mentioned this evening. So we're looking at heat pumps first, and then finally insulation. And you can find all the information and registration links for those webinars on the Cosy Homes website, and just click on events in the main navigation tab. Otherwise, it just remains for me to say a huge thank you to Doug for joining us tonight to share his knowledge and expertise with us all. And a big thank you to all of you as our audience for joining us this evening and asking so many interesting and perceptive questions, and really engaging with the content. It's been really great. So yeah, that's it for tonight. And thank you all for coming, and hopefully see you next time.
Thanks very much. Yeah, thanks for the opportunity and interest, I should say.
You're very welcome. All right. Bye for now, everyone.